Today we are going to discuss the topic 1 of our GCSE course, which is energy. Uh, in our first lecture, there are certain topics that we are going to cover. So I'm just going to tell you first which of those topics we are going to discuss today. The first topic that we are going to discuss is energy stores. But before explaining how energy stores works or what are the energy stores, we need to understand something out of this topic which is really related to this topic is the system. Then the next thing we will move toward again energy stores and some universal statement about energy. In physics we use the term for that is law. This kind of statement, usually we use the term for this kind of statement is law. Then various types of energy stores. Let's just start one by one discussing everything. The first thing is energy. So what is energy? If you want to define it at this level, energy is the ability of a body to do work. That's something to remember, because there is something work that we haven't discussed yet. In physics, work is a bit different than the term work that we use in real life. So the main topic that we are going to discuss in the first portion of our lecture is energy stores. But before moving towards to the energy store, let's just discuss what is a system. A system can be an object. What can be a system? System can be an object, volume, or any part of the universe. What will we call a system? When an object, a volume, or any part of the universe is under the observation. So if I want to define a system, I would simply say that the part of universe, if you are looking at a box in which you have placed certain balls, they are your system. I'm teaching a class, my students are my system. Or a scientist is observing entire galaxy, the galaxy can be that system. So a system is always separated from its surrounding by a boundary. The other term which is associated with system is the boundary of a system. So there is a system, then there is outside. Everything other than the system is called its surrounding. Every part of the universe other than the system is called its surrounding, and the boundary that differentiate between the system and the surrounding, the border that differs between the system and surrounding is called the boundary of a system. Then there is a special type of system which is called closed system. We'll come back to this closed system after we discuss a bit about energy stores. So energy stores is every object in universe has certain stores associated in it, and they store energy in their stores. So whenever there is energy, there are, let's say I have an object A. Object A has certain stores within it. Okay, say A, B, C. That's for simplicity we are calling these stores name, and each store stores a special kind of energy. So various kind of energy stores will store different kind of energy within themselves. Okay. There is something universal about the energy, and that universal thing about the energy is that energy can never be created, or energy can never be used. So I can use two parts, that energy can never be created, and the other part that we are going to discuss of that statement is energy can never be used. So what we have studied so far is the energy, that is the ability of a body to do work, and then we move on to the system, which is the part of universe that is under observation. Okay, and then we move toward the energy stores, and we know every object in the universe has different kinds of energy stores associated with them, and different types of energies comes to their respective stores. So what kind of stores are there within the system? Okay, so the kind of stores that are present in the system are the following. Let me write them down for you. There is thermal energy store, electrical energy store, nuclear energy store, thermal, electrical, nuclear, electromagnetic, and mechanical energy store. Mostly in physics, you will be dealing with the mechanical energy store and thermal energy store, but it does not mean that the other types of energy store won't come into discussion. But at this level, mostly we will be discussing about mechanical energy store and thermal energy store. Okay. Similarly, you can say gravitational for mechanical energy store. So there is, let me just change the color, gravitational potential energy, similarly elastic potential energy store, and kinetic energy store. These are some examples of different types of energy stores. There are other energy stores as well. For example, chemical energy stores, because matter reacts with each other and they give off chemical energy, and many other types of energy. So there are many types of energy, and all these types of energy will always go into their respective stores. This is what we have discussed so far with this topic. The different types of energy stores is what is energy system, then energy stores, what is the property of energy, and various types of energy store. Similarly, there is a small topic associated with this topic is the transfer of energy. So energy has this property that it can transfer from one store to another store. That's where the system comes into the play. So whenever there is energy in a system, and by system we mean object. So that's why I defined the system in the beginning. Instead of calling an object, we will be using the term system. That energy is stored in the, all these stores are associated with the system, or all these energy stores lies within the system. Okay. So whenever there is energy in a system, it can move from one store to another. So let's say we have our system here. So we have a system here which I'm calling a system A, and my system A is my car. Okay, so this is a really funny car though. I'm putting two wheels underneath it and it's moving, and there is, let's say, a simple heat engine inside it. Okay, so when there is a heat engine, it means there is a thermal energy or heat energy. Where is thermal energy coming from? Thermal energy is actually coming from the chemical store of the fuel, because when the fuel is burning, there is a chemical reaction happening, and from the chemical energy store, so there is one store which is chemical energy store, and from chemical energy store, heat is moving toward energy is transferring to heat energy store, and from heat energy stores it transfers toward, because it moves the car, so it transfers to the mechanical energy store. So from heat energy store, then it transfers to mechanical energy store. So within a system, energy transfers from one store to another. So the universal statement that we wrote, energy cannot be created. Energy is coming from one form to another, and energy cannot be used. From mechanical energy, energy goes from system to the surrounding by friction, by producing, because cars produce sound, so the sum of energy is transferred to the surrounding stores of the sound energy, and similarly some of the energy is transferred to the frictional force energy by doing work. So we will be discussing work in the next topic. That's really important. One tip that I need to give you for your exam is, when you are solving your exam paper and there is some discussion about or some questions about transfer of energy, you should always refer to energy stores. So that energy, like you can say chemical energy, energy is being transferred from chemical energy store to heat energy store, and then from heat energy store to mechanical energy store. So that's how you should use the term store with the energy to make yourself clear. Okay, so that was about different types of energy stores. System has two types. One is called closed system. If there is exchange of matter and energy from surrounding to the system, it will be called as an open system. Closed system is if there is no change of matter or energy between. So for closed system, ideally the universe is a closed system, but in laboratories we can make a very near to systems that are very near to closed system. Open system, any system in the universe that you see there is matter is being exchanged and energy is being exchanged is called open system. There is another type of system too, which is called isolated system, but that's not the scope of this course, so we won't be discussing it. With this topic, with this we have concluded this topic. Now the next topic that comes with the energy is work, and we need to define energy in terms of work. Okay, work done. In the previous part of our lecture, we discussed that how energy is transferred in different energy store. Now for the term that we used, that energy is transferred, we are going to use a fancy name and another name for the transfer of energy, and that is called work done. So whenever energy is transferred from one store to another, it requires work to be done, or in simple words you can say whenever there is a transfer of energy, it means that work has been done. So the transfer of energy is actually called work done. So in physics, energy can, what we can write is energy can be transferred by doing work. Energy can be transferred from one store to another store within the same system or different systems by doing work. So this is how we can define work. The energy can be transferred from one store to another store within the same system or different systems by doing work. Or it can be system and surrounding. So if somebody is observing the surrounding, that becomes the system for them. So whenever there is a work done, there will always be an expenditure. There will always be an expenditure of energy in term that it will be transferred from one place to one store to another. Again, you can look at one example where a car is moving. So we have this car and it is moving, and the driver applies the brakes suddenly. Now when the driver applies the brakes, there is a frictional force between the tire and tire of the car and the road. So when he applies the brakes, actually the tire stops rotating and the frictional force increases. When the frictional force increases, now frictional force is always, keep in your mind that the frictional force is a kind of force which always act opposite to the direction of motion. If car is moving this way, frictional force is acting opposite to that direction. But if the car start moving this direction, frictional force will be acting opposite to it. So this frictional force, the magnitude of this force increases and it compels the car to stop. So if you are looking at it in terms of energy transfer, what is happening is the car is transferring its mechanical energy from its mechanical store to the thermal energy store of the road. So there is a transfer of energy between car and the road. From the car, the mechanical energy, that is kinetic energy, is being transferred to the thermal energy of the rod. And not only thermal energy, whenever there is a sharp back is applied, we also hear sound. So it is also converted into sound energy, which is dissipated into the rod and surrounding air molecules. So energy from kinetic energy store is transferred to various stores. Similarly, when a car is moving, there is also a frictional force acting on it from the air and from the road, and still the tires of car get warm because the kinetic energy is continuously transferring to another energy store. And this transfer of energy or this stopping of car, but why did the car stop? Because we say work has been done on the car for it to be stopped. So the work done, by work done, we mean who did the work? The frictional force. And by work done, we mean that energy has been transferred. So that's how energy transfer. Similarly, if we have an object at certain height, falling object. So whenever an object is on a certain height from the ground, it has an energy stored in it, and that energy is called gravitational potential energy. When an object is at a certain height, it has a kind of energy stored in its gravitational mechanical energy store. And if you look at mechanical energy store, it has two compartments in it. One is kinetic energy store and the other is potential energy store. Potential energy store is a big hall in which we have, so this is potential energy store, which has different types of potential energy stores like gravitational potential energy store, elastic potential energy store, and other kinds of potential energy stores within this store. Okay, so when an object is at a certain height, it has gravitational potential energy stored in its gravitational potential energy store. I have this object which is at this height, and now I push it to fall down from this height. So when it starts falling, its energy from gravitational potential energy store starts moving toward kinetic energy store, and as it is falling down, it speeds up. Its speed increases, and with increase in speed, more fast the potential energy transfers to the kinetic energy store. So the faster it moves, the faster is the transformation of potential energy to the kinetic energy store. So actually the energy is transferring from potential energy store to kinetic energy store. And so when it reaches the ground, just before hitting the ground, all its energy from gravitational potential energy store moves to kinetic energy store. And we say that because the energy has been transferred, so there has been the work has been done by a falling object. Okay, what has happened here? At this point, object has energy in its potential energy store, but when it reached here, all its potential energy has been transferred to kinetic energy store. So if I want to write it in terms of an equation, in terms of mathematics, how would I write it? I would write it that energy from gravitational potential energy store is equal to energy loose from or energy transfer from gravitational potential energy store is equal to energy stored in kinetic energy store. So let's just write it in form of an equation for gravitational potential energy store to kinetic energy store. So for a falling object, the rule loss in energy, gravitational potential energy store, is always equal to gain in energy in kinetic energy. So we can say simply that for loss or for change, we usually write this Greek letter delta. Gravitational potential energy, let's just write EG, which will say gravitational potential energy is equal to change in kinetic energy EK. So this is one of the most important equation which is related to energy transformations when we are talking about energy or work. So loss in gravitational potential energy is always equal to gain in kinetic energy. Okay. Yeah. So in this work done topic, what we have studied is work done is actually the transfer of energy from one store to another, and whenever there is a transfer of energy, we say that work has been done, and we can actually understand how it has been done. The other thing that we have studied is whenever an object falls, its energy from gravitational potential energy starts moving to kinetic energy store. So that's what we have studied in this lecture, in this topic. Okay.